Hi everyone, welcome to helpyourmath.com. My name is Britannia Rose and today we're doing multiplication of square root. Now when we multiply square roots, we only multiply like terms. So what I mean by like terms. All right, let's take the example 3 times the square root of 2 times square root of 5. Now first, the square root of 5, we know there's a 1 here. Now, when we multiply like terms, we mean we're going to multiply 3 times the 1. We're not going to multiply 3 times the 5 because 3 is outside the radical and 5 is under the radical. So we cannot multiply their numbers. We can, however, multiply 2 times 5 because they're both under the radical. So let's multiply this. We're going to have 3 times 1 times the square root of 2 times 5. Here we're going to have 3 times the square root of 10. You can't, now the next step will be to simplify the square root of 10. But as you can see here, 10 cannot be simplified any further. As you can see, the product of 10 is 2 times 5, which are 2 prime numbers. And there's no pair, so this will be our final answer. Now if we were to have simple one, we're going to have 2 times the square root of 3. Let's put the square sign there. Here, we have 2 times the square root of 3. 2 is not under the radical. 3 is. And because 2 is not under the radical and 3 is, we cannot multiply their numbers. So the final answer for this would just be 2 times the square root of 3. That's the final answer. Now, the next example would be 5 square root of 2 times 2 times the square root of 6. Now here, again, only multiply numbers that are outside the radical and numbers together that are inside the radical or underneath the radical either. So we're going to multiply 5 times 2, and then we're going to multiply 2 times 6. Here. We can't multiply 5 times 6. 5 is outside, 6 is underneath, so we cannot multiply them. Only need to multiply numbers that are outside together, only. So here we're going to have 10 times the square root of 12. Now 12, unlike 10, the square root of 10 can be simplified. So I'm going to do this in terms of the perfect square, which we know would be 4 of the 12. So this would just be reduced to as 10 times 2 of 3, which would give us 20 radical 3. Again, when we take the square root of 12, we know a perfect square is 4 times 3. If I were to write this out, this would be the square root of 4 times 3, which would give us 2 and times the square root of 3. Because we can't reduce 3, we'll leave it as it is. And that would be 20 times the square root of 3 would be our final answer. Now, if we were to have a special rule code that we know, and it states that if you were to take the square root of x times the square root of x, your answer would just be x. So if we have the square root of 12 times the square root of 12, our answer is 12. Now we can prove this fact here. So we're going to do this by prime numbers. So again, you want to list out your prime numbers of 12. So you can have 2 times 6, and you can have 2 times 3. So let's list out the prime numbers of 12. So we're going to have the square root of 2 times 2 times 3 times the square root of 2 times 2 times 3. again, as you can see, we have 2 2s here. And well, actually we have 4 2s and we have 2 3s. So we're gonna take out all the pairs. So we're gonna rewrite this as 2 times 2, and then we're gonna have 2 times 2 times 3 times 3. Now, I got 3 times 3 because, as you remember, when you multiply numbers, if they're both under the radical, we can multiply their number together. So even though this only has 2 times 2 times 3, and this only has 2 times 2 times 3, because both these three are under a radical, I can combine them and create a pair. So, remember correctly, if we had 2 numbers that are under radicals, we have 2 times 2, our answer is just going to be 2. Here, same thing applies, it's going to be 2 times 3. And if we multiply this out, 2 times 2 gives us 4 times 3, which gives us 12, which is the same thing we got if we just multiply it out. Now, we're going to take it up a notch. We're going to add and subtract while we're going to multiply. So if we were to have, for instance, the square root, not the square, 6 times the square root of 5 times the square root of 5 plus 2 times the square root of 2. As you can see here, these two expressions are within the parentheses. So that means we have to simplify anything within that parentheses first. First, we see that 5 and 2 are not the same number. They're both under the radical, yes, but they're not the same number. And because we're adding and we're not multiplying, we're adding here, we can't add them. So we leave it as it is. And we can't reduce 5 and we can't reduce 2. So we'll leave it as is. The next step is to multiply 6 times radical 5 to both expressions. So we're going to distribute it out. And so I'm going to have 6 times radical 5 times radical 5 plus 6 times radical 5 times 2 radical 2. Again, we know there's an imaginary 1 here, so we only multiply the coefficient by coefficients and number that's under the radical by numbers under the radical. So this we know is going to be 6 times 5, which we get because we have radical 5 times radical 5, which will just be 5, plus this should just be 6 times 2 times radical 5 times 2. This will give us 30 plus 12 radical 10. And since 30 does not have a radical beside it and it's not radical 10, we can't do anything. This will be our final answer. Now, next example. Next example would be if we were to have radical 3 times 18, radical 18 minus radical 8. Again, we have to simplify anything within the parentheses first. So first here we have radical 18 and we have radical 8. We know these can be simplified, so we're going to simplify them first. We're going to do them in terms of perfect squares. So we're going to have radical 3 times square root of 9 times 2 minus the square root of 4 times 2. Again, we know this would just be radical 3 times 3 square root of 2 minus 2 square root of 2. Again, both these expressions have square root of 2 beside it, so we can just minus the coefficient. So this would just be radical 3 times square root of 2. And since both these numbers are under the radical, we can multiply them together. So our final answer here would just be square root of 6. So our Last example would be, negative 2 times the square root of 7 times the square root of 7 plus the square root of 2 minus the square root of 8. Again, simplify anything within the parentheses first. So here we have the square root of 8. We know this can be simplified, but we cannot simplify 7 and 2. So let's just simplify the square root of 8 first. So this would be negative 2 times the square root of 7 times the square root of 7 plus the square root of 2 minus 2 times the square root of 2. Now, as you can see, these two expressions both have 2, square root of 2 beside it. And as we know, right here is an imaginary 1, so we're going to simplify this expression, these two expressions. We're going to minus their coefficient. So this will just give us the square root of 2 times the square root of 2. Negative 2 times the square root of 7, times the square root of 7 minus the square root of 2. 1 minus 2, we could just, again, this would be imaginary 1 in front of it, just be negative 1. So now we're going to distribute negative 2 square root of 7 to both expressions. So we're going to have negative 2 square root of 7 times the square root of 7 minus negative 2 the square root of 7 times the square root of 2. And this would just be negative 2 times 7 minus, and keep your parentheses because we have a negative here, so keep your parentheses, minus negative 2 times the square root of 14. Again, we do not multiply 2 by 2. It is outside the radical, so we cannot multiply these two numbers. We only can multiply these. So again, we know since we have two negatives right beside each other, this becomes a positive. So this would be negative 14 plus 2 times the square root of 14. And since we can't simplify 14 any further, we leave it on the radical. And as we can see, negative 14 does not have a radical beside it. This would be our final answer.